Question 9 says graph the following equations on one set of axis. It should be axis. So I've given you a Cartesian coordinate plane here, and I've asked you to graph two relationships, and actually I believe they are functions. And if I look at this first one, it is y is equal to x minus 6. Now we do know something about slope-intercept form, and we can graph this quickly. But if you panic and you forget all those things, don't. Just relax and remember, look, it's just a matter of finding x, y values that we're going to graph. So I could pick some x values and then calculate the y's that go with them. So for example, if I picked x was the number 0 and I put these x values into the function right here, right? Well, when x is 0, I end up getting a y value that's equal to negative 6. So that's one point I can graph. If x is 1, 1 minus 6 is negative 5. If x is 2, 2 minus, I'm sorry, I said 2, 2 minus 6 is negative 4. If x is 3, 3 minus 6 is negative 3. So a lot of values there, and I can come back over and I can plot that relationship. So at 0, plot the point negative 6, so right here. At 1, I'm plotting negative 5. At 2, it was negative 4. And at 3, I believe it's negative 3. So that's certainly enough information for me to graph this line. And I would grab my ruler at that point and connect those dots. But moreover than that, and I don't like where that line hit there. I need to be a little bit lower. But more than just that, I can look at this now and I can remind myself of some important things, right? This equation, y equals x minus 6, is written in slope-intercept form, right? There is no visible slope there, so I know that m, my slope, has to be the number 1. So it's just up 1 over 1, up 1 over 1. And I can see my other parameters, my y-intercept, b. B's happening at negative 6. And yes, I got the points by plugging in x values and calculating y's. But notice when I look at my graph, I can see, my y-intercept really was at negative 6. And it did have this slope pattern being up 1 over 1, up 1 over 1, up 1 over 1. There. So that's a more efficient way to graph, and I'll probably do that with the next question. However, the next question, you'll know that it is not in slope-intercept form. It's so close, right? Form would look like that, like not that. It would look like I make this drop. It like y equals mx plus b, and I'm so close, except I have a 3 here on this side. So what I'm going to do is I'm going to multiply each term by the number 1/3, or I can divide every single term by the number 3. If I divide this first term on the left-hand side by 3, I get simply y, right? 3y divided by 3 is y. The next term, x divided by 3, I can write it as x over 3, or I can write it's 1/3 of x. And then the last term, 15 divided by 3 is 5. So here I can see both of my parameters, right? I can see my slope parameter is the number 1/3. And the other thing that I can see is my y-intercept parameter is negative 5. So I'm going to have a y-intercept at negative 5, and I'm going to observe the pattern of up 1 over 3 units. So if I come back over to my graph right here, this one's going to begin at, I didn't want to do that. It's going to begin at 5, and then it's going to go up 1 unit and over 1, 2, 3 units. So that's my second point, up 1 over 1, 2, 3 units. And I'll just follow that one more time. I'm just going to go up 1 and over 1, 2, 3 units. So this is my graph. I messed, oh no, I didn't mess up. It's only I was looking at that negative 6 y-intercept. So this is the second graph that I have. It has a y-intercept of 5 and a slope pattern that is 1/3, up 1 over 3. So I now have both of my functions graphed, although I should extend that line a bit, but I'm not going to worry about it. Just put an arrow here and here. So this is the graph for A, and this is the graph for part B.